What if you could make your React app 10 times faster and 10 times smaller at the same time? Let's build a simple React app. We will use Ultimate Express, the fastest web server. Yes, built for compiling JSX and TypeScript, and of course React and React DOM. And let's not forget typings. Now I'm going to set up a basic project structure. I will start by setting up a web server. For now, just a simple Hello World response will be enough. Next, I need to add build and start scripts. ESBuild is really fast and it's become one of my favorite tools. Okay, now we're ready to run it and see if it works. Build is done. Let's check it in the browser. Looks like it's working. Now it's time to add some React components. I want to keep it simple with minimal interactivity. A plain hello world isn't enough, so let's add a counter and the button to increment it. I will also set up an outer HTML container for my app component. Our simple server-side rendered React application is almost ready. The only thing left is to implement render to string. Alright, let's build it and check if everything works. Let's refresh the page. Looks good. But the button doesn't work, because right now we only have static markup without a client bundle. Now I'm going to create a hydration script. It will load in the browser and initialize our application on the client side as well. The next step is setting up the client bundle build. Cursor's autocomplete is as useful as always. I also need to set the mount point and make sure the bundle is included in the HTML. We've got the JavaScript bundle, but it's not served over HTTP yet. Let's solve that by adding a static file handler. Start it, check it, and it finally works. But that's too simple. Real-life applications and websites usually have much more content, so I'm going to add a large list of numbers to make the rendering process feel a bit more realistic. Perfect, that's exactly what I need. Now let's check the bundle size. It's almost 200 kilobytes, but usually we don't transfer it without compression, so let's check the compressed size. A bit over 50 kilobytes, not too bad, but it could be better. Now let's start it again and do some load testing to see how many requests it can handle per second. 100 RPS is actually quite a realistic result for an average React app running on a single thread. Let's try to improve its performance. First of all, I don't need the React dependencies anymore, so I'll just remove them. I'm going to use an alternative, a fast and lightweight library called Preact. It has some minor differences, but there is also a compatibility layer, so we don't have to rewrite our app. To make it work, I will set up aliases from React to Preact/compat. That's it. It's ready to run. The bundle is smaller now, and it even works. Let's run the load test again with the new configuration. As you can see, it now handled 20 times more requests, and I haven't even changed the code. Finally, let's take the last step and adapt the application to use pure Preact for maximum performance and minimal bundle size. This is an optional fix. Now I'm going to configure TypeScript for proper JSX transpiling. By default, it generates React imports, but that's not what we need. Here we just need to replace the package that exposes the render to string function. The biggest change is in the hydration script. We not only need to replace the import, but the new hydrate function also has a different argument order. Finally, let's clean up the last outdated imports and we are ready to see how it all works. Well, it's still working fine, so let's run a load test and see if there's any improvement. That's over 3000 RPS versus just 100 when using React. Let's look at the bundle size. 18 kilobytes is much better, but don't forget about compression. Just under 8 kilobytes. I'd rather have nothing, but it's way better than 50 kilobytes with React. Finally, let's take a look at the final result. If you care about performance and server costs, always keep an eye on alternatives. The most popular isn't always the most efficient.